Hello, Morgan Labs. We're talking about waves. This is kind of part 3. I talked about first the interference of two waves, the phase angle, and then I mentioned there would be things that interact where you would need that phase angle. Part 2, I just did a simple harmonic problem, just something oscillating, and then we figure out amplitude, omega, things like that. So part 3 is kind of all putting it together. AC circuit analysis. So AC, what we mean by AC is that we have some voltage source and it's pushing electrons through the circuit, right? And then it reverses and it pushes them the other way, right? AC, right? Back and forth. So it's just going back and forth, back and forth, back and forth, back and forth. Now, for our purposes, okay, I'm just showing here like this is what DC looks like. Just a battery that would you put like in a toy or something, and the current would just flow one way, one direction. This is showing AC, where the voltage would go +5, -5, +5, -5. And there you can see the simple harmonic motion, the kind of like wave kind of thing that we're talking about in this series. Okay, let's go up. When we deal with DC voltages, we use Ohm's law. Voltage equals current times resistance. In AC circuit analysis, we use a slightly different form of Ohm's law. I don't know if it has a particular name, but instead of going V equals IR, you go V equals IZ. Z is impedance. In impedance, we have separate equations that we use for capacitance, resistance, and inductance. I'll get into that later. But right now, I would just want to talk about using phasors, what we call phasors, and how we can do circle analysis a simple way, just using this phasor kind of notation. So the problem would be you have a 120 volt AC source with frequency 60 hertz. And then we ask, okay, there's an impedance of 9 phasor 25. And we want to find the current. So to find the current, what would you do? You would go V equals IZ. You put the Z on this side here. And it'd be V over Z equals I. And that's what we do. Okay. And when we do that, those equations, right? I said I'll talk about that later. You'll have equations for the resistance and capacitance, and they'll equal this 925. So a phasor, all it is a different notation of the thing there. So okay.